So, hi there. Welcome to lesson one. We will be looking at integers, decimals, limits, and outliers. So, just pay attention. It's basically a theoretical class. We're building it up, and then we'll now start looking at how all these things connect. So, integers and decimal. So, let's look at this man here. So, how old do you think this man is? 0.8 years, 8 years, 80 years, 800 years, or 8,000 years. Look at him. I mean, take another look. You can pause the video if you want to. I'm going somewhere, so but it's very important that you just try and answer the question in your mind. So now this takes us back to domain knowledge. By looking at him and your experience in life and what you know about life, you should be able to make an intelligent guess. He cannot be less than half a year. He cannot be less than 10 years old. He cannot be up to 800 years, and he cannot even be 8,000 years. So basically, these numbers I had quoted about his age can be put in some sort of continuum. That's why we call it a continuous variable, you know, a continuum. And I put infinity there because 800 years will be somewhere very close to the end, and then 8,000 years very close to infinity. I don't know anybody living there, but you see, less than 1 year. So just putting them on a what we call I'm trying to remember in our secondary school education, a number line, so you can find them. So they're on a continuous spectrum. And in some cases, you even have the minus section where you have -1, -2. I'm sure you may have done this in your maths class in the lower, I mean, in secondary school. So all I'm trying to establish here is that we have what we consider to be the appropriate. Now, the oldest man in the world is 122 years. I hope my research is right. So please, if it's wrong, please just correct me in the comments. That's fine. I would adjust. So So the oldest man, so definitely 800 and 8,000 cannot be correct. So basically, that's the concept of a continuum. So whether it's an integer, as you soon learn, or a decimal, it has a spectrum. That's the point. And then there is a spectrum that is what's the word? That is right. Like for age, nobody can be -5, nobody can be -10. So this is where context comes to meet and interface with data. So that's what a continuous variable is. It can be anything from -1 million to +1 million, or -1 billion to +1 billion, or -1 trillion to +1 trillion. So there are numbers there and they are variable depending on the context. So nobody should be -50 years old, just saying. And nobody should be 5,000 years old too. So there's a range. And that's what is very interesting about continuous variable. So you can have 5.1, 5.111111, 5.11111112. So it's infinity, like they say sometimes. There are so many possibilities that can happen. So let's look at the two types of continuous variables. One is the integer, you know, basically it's just a whole number, completely whole. And decimal is a part. And that's why you see 4.5, 3.5. But for context, there are certain places where you use um, integers. You cannot say 1.5 human beings, 2.5 dogs. Nope, not correct. But you can say 1.5 bags of rice, 1.5 kilograms. That is possible. So it's not. So even though the whole idea between for these numbers is measurement, there are certain conditions that have to be met and context that has to be understood. So be very careful to when you are being told to treat an integer for a decimal. So we said 1.5 people did this. So the best we do in data is to round it up or round it, down, you know, give it something that is realistic for someone to use. So you can say four out of every five people um, take the bus in the morning. But when you say 4.5 people, it's not really, you either round it up to five or you round it down to four. You say at least four out of every five people take a bus in the morning. So it's very important to know the context. Also, very important, an integer can be swapped as a decimal and get away with it, you know, but the decimal can be in danger too. So it's just best that they be in their ideal roles. So what I mean by that is I can still say 2.0 human beings and I'll be correct because that's whole. So anything that ends with a point zero is a decimal in a way, but it's actually an integer. And I can also say, an integer is 2.0 and be seen as a decimal. That's what I mean about marriage. But it's very clear, it's very important that you are clear about the context in which they are used. So please bear this in mind because it's very important to separate integers from decimals. And it has put a lot of people in danger, not danger, sorry, in trouble with the data when they cannot differentiate. So you may want to just uh, not, I don't want to use the word modified there. Yeah, but that's the word, modify it if it's supposed to be an integer. Probably you got an average and you want to round it up or round it down. There are functions like that. It's beyond the scope of this course, like ceiling and floor, that greatly help you to manage this kind of demands. So, thank you. This is how we're going to do it. Integers we've mentioned and decimals we have mentioned, and we have talked about a spectrum where they can exist. And that spectrum is based on context. To use temperature as an example, that 100 degrees centigrade is ideal maybe for is maybe for temperature of the earth or temperature of the inner crust of the earth, but it's not ideal for a human being. No human being can exist on 100 degrees Celsius. You will have been dead. The average human temperature, in my understanding, is 37 degrees centigrade. So, or Celsius. So that's context, very critical. So the same 100 is okay for weight. Maybe someone is 100 kg. And then there's a weight you attain. You cannot be 5 tons. No human being can be 5,000 kg. I don't know if there's any that is as heavy as that. So we must always understand limits. We must also understand the format and the structure, whether it's an integer or a decimal. So when we start applying some of these things in the practical sessions, I'm sure it will sink, especially when we go and work on the collapse command. So let's hold on here. We're going to the next lesson again, and we're going to take it a bit deeper based on what we have learned. Everything we are doing currently is just, addressing continuous variables. And when we get to lesson 5, we'll be talking about the other variables, which are basically the categorical or string variables. Thank you so much for your time, and I will see you in the next video where we'll be talking about minimum, mean, and max. Thank you. See you in the next video.